Assalamualaikum warahmatullahi wabarakatuh. My name is Hadi bin Zakaria and my theme for this presentation is Wan Ahmad Imran, Ifah Oni and Siti Nurhanis. As we know, many things existed in this universe, but the smallest thing in this universe is atoms. In 1802, John Dalton formally stated that everything is made up from atoms. Then, scientists discovered that these atoms can be associated into molecules, ions, crystals, and other stable forms that make up for familiar substances for everyday world. And all of this is called chemical bonding. But knowing all of this, have you ever wondered, for instance, how does this chemical bonding occur? In the early of 12th century, a speculation about the nature of chemical bond is already made up, where certain types of chemical species supposed to join by a type of chemical affinity. Then, in 1704, Sir Isaac Newton famously outlined his atomic bonding theory, where atoms attach to each other by some force. Basically, chemical bonds are stable attraction between atoms, ions, and molecules. The formation of chemical bond allow the formation of molecule or compound. It is important to know that these chemical bonds are classified into several categories, which are covalent bond, ion bonds, metallic bonds, and hydrogen bonds. The strength of the chemical bond may vary into two types, which is strong bonds, or we call it as primary bond, and weak bonds, or we can call it a secondary bond, where covalent bond, ion bond, and metallic bond are classified under primary bond, and hydrogen bond are classified under weak bond or secondary bond. Clear? Covalent bonding is a common type of bonding where two atoms will share its valence electrons more or less equally. Next, ionic bonding is an electrostatic interaction between atoms that have a large electronegativity difference. Other than that, metallic bonding is a type of chemical bonding that arises from the electrostatic attractive force between conduction electrons and positively charged metal ions. Lastly, a hydrogen bond is a primarily electrostatic force of attraction between a hydrogen atom and electronegative atom. In this presentation, my groups will present to you guys more knowledge about hydrogen bond.
Characteristic of hydrogen bond. Hydrogen bond is an intermolecular attractive force in which a hydrogen atom that is covalently bound to a small, highly electronegative atom is attracted to a lone pair of electrons on an atom in a neighboring molecules. Hydrogen bonds are very strong compared to other dipole interactions. Hydrogen bonding occurs only in molecules where hydrogen is covalently bound to one of three elements, such as fluorine, oxygen, or nitrogen. These three elements are so electronegative that they withdraw the majority of the electron density in the covalent bond with hydrogen, leaving the H atom very electron deficient. The H atom nearly acts as a bare proton, leaving it very attracted to lone pair electrons on a nearby atom. The hydrogen bonding that occurs in water leads to some unusual but very important properties. Most molecular compounds that have a mass similar to water are gases at room temperature. Because of the strong hydrogen bonds, water molecules are able to stay condensed in the liquid state. In the liquid state, the hydrogen bonds of water can break and reform as the molecules flow from one place to another. When water is cool, the molecules begin to slow down. Eventually, when water is frozen to ice, the hydrogen bonds become permanent and form a very specific network. The band shape of the molecules leads to gaps in the hydrogen bonding network of ice. Ice has the very unusual property that its solid state is less than less dense than its liquid state. Ice floats in water. Virtually all other substances are denser in the solid state than in the liquid state. Hydrogen bonds play a very important biological role in the physical structures of proteins and nucleic acids.
Hi, my name is Wanama Imran Berosli. My metric number is 200703. Now I'm going to talk about the properties of hydrogen bonding. First is the solubility. Lower alcohol are soluble in water because of the hydrogen bonding which can take place between water and alcohol molecule. Second is volatility. As the compound involving hydrogen bonding between different molecules actually have a higher boiling point, so they are less volatile. Third is viscosity and surface tension. The substance which contain hydrogen bonding exists as an associate molecule, so their flow becomes comparatively difficult. They have higher viscosity and high surface tension. Number 4 is the lower density of ice than water. In the case of solid ice, the hydrogen bonding gives rise to a cage-like structure of water molecule. As matter of fact, each water molecule is linked tetrahedral to form water molecule. The molecules are not as closely packed as they are in a liquid state. When ice melts, this cage-like structure collapses and the molecules come closer to each other. Thus, for the same mass of water, the volume decreases and density increases. Therefore, ice has a lower density than water at 273 Kelvin. That is why ice floats. That's all from me. Thank you.
Right now, I am going to talk about the application of hydrogen bonding. Hydrogen bonding is applied in inorganic molecules such as water and organic molecules such as DNA and protein. Hydrogen bonding helps water in order to achieve its unique properties such as high boiling point and surface tension. Hydrogen bonding helps organic molecules such as DNA, in which it helps to hold the two complementary strands together. Hydrogen bonding also helps proteins as it is partially responsible for the structure of proteins by helping the protein to form and maintaining the specific shapes. That's all from me. Thank you.